So welcome. Thank you for coming today and listening. And if you're listening to this in a recording, feel free to contact us at the end of this with the contact Kenexis form that you'll find on most of our website pages or under the company tab at the top. Today's seminar or webinar will be on, can I see your functional safety management program documentation, planning functional safety with template procedure, and Ed Marzell is going to deliver it. What I'd like to do real quick is walk you through our learning management system. And I have logged in real quickly to it, so you didn't see me log in. I apologize, but there's actually a common login. And when you get into our system for all of the software products that we have, I've logged in just like you would basically. And I don't have any products assigned to me or anything, but I wanted to show you the training suite real quick. The learning management system enables other people to actually use this as their own learning management system and also take advantage of all the process safety training that we built into the system. So just to show you real quick, here's the list of my courses. There aren't many in my system or in my bucket, so to speak. But if you click on Browse Available Courses, you get an idea of the courses that are available, not only on the software, but theory courses, things like the safety requirements specification, safety instrumented systems overview and awareness, LOPA participation. And so some of these courses are more like a webinar where we teach. Some of these are actually classes, very much like you would attend in a classroom where the instructor's talking to you, and you have quizzes and tests and certificates that you can pull out of the system. So just the FYI, it's a really good system, and that's enough of a commercial for today. So Ed, if you don't mind, you could take control and present.
Absolutely, will do. Let me go ahead and share my screen. And I will get into the course content. As you can see, I'm going to be showing my whole desktop because I'm going to be jumping in and out of things as we go through the course for the rest of the day. So I'll be doing things like I will be looking directly at the standard. I'll be looking into our software suite, and I will also be looking at some slides. I will be looking at a document. So now one of the first things is that we're going to be looking at this SIS Safety Lifecycle Management Standard. So this is the Kenexis boilerplate. It is free. So if you go into the training, and a lot of the content from today's course is going to be from the SIS Management Responsibilities training course. So if you look at SIS Management Responsibilities, there's about an hour and a half of lecture and associated quizzes with this course. But when I go into the course, over here in the top left side, where there's the table of contents of the training course itself, there's also this course documents section, which is where you can download documents that are associated with the course. And one of those documents is going to be the SIS Safety Lifecycle Management Procedure Template, along with our SIS handbook and the workbook and study guide for this course. Now, in order to make things flow a little bit smoother, what I've done is I've given access, and let me see if I can make this, let me crank the zoom very significantly. So actually, you know what I'm going to do is that this is how you get the download right now while we're in this class. So there's a link right here to the Kenexis website, and then there's a password. You'll be able to go onto our server into that folder and download the document itself. So what I'm going to do right now really quickly is I'm going to open up the chat, and I'm going to paste that information in so that you don't even need to try to read it and type it. So that is where the template document is. You could go onto our server and download it right now. Okay, so let me start out by going into the PowerPoint slides. And again, this is for the overall SIS management class, but I'm only going to go over section 2 of this class, which is safety planning. So in terms of safety planning, this is all going to be in clause 5 of the 61511 standard. We're going to talk a little bit about planning requirements. What do you need to plan? What do you need to think about in terms of a corporate standard, a site standard for how to implement the SIS safety lifecycle? And then we'll also look at what are the tasks that need to occur over the course of the safety lifecycle. We'll begin by talking about what the requirements are, and then we will go into the template corporate standard to see how we at Kenexis believe is the best approach for a corporate standard for implementing these planning requirements. Okay, so we start out in again, I said section 5 is where management and planning is discussed. And in 5.2.4, there's a clause on safety planning that says safety planning shall take place to define the activities. So we need to define what tasks need to be done, who is going to be doing them. So what are the activities that are required, along with the persons, departments, or organizations that are responsible to carry out the activity. And the planning shall be updated throughout the entire safety life cycle. So as times change, as organizations change, you're always going to need to keep your eye on this standard to make sure that it's up to date and appropriate for what you're doing. And also, you need to do this activity to a level of detail that's going to be commensurate with the role that any individual or organization has in terms of performing their SIS safety lifecycle tasks. So generally, all of this information is going to be contained in a site standard or a corporate standard. And that standard is going to include a list of all the tasks that need to be performed, and then a discussion of who is responsible for performing that task. The required inputs, the required outputs, and the tools to be used when you're executing these activities is what this document is going to include. Now, the slide that you see here, I'm sure, is extremely familiar. It is the safety life cycle in accordance with IEC 61511, and it talks about a variety of tasks that are going to occur over the life cycle. So you have your risk assessment tasks that are assigning performance targets to the safety instrumented systems. You have your design tasks where you're actually programming, configuring, wiring up the safety PLC. You've got installation and commissioning tasks during construction, just to get it built, to get it installed, to get it tested, to make sure that it operates. And you're going to have operational tasks. So once the SIS is in the field, that's not the end. You need to operate it, you need to maintain it, you need to test it. There are going to be continuing modifications that you need to carefully execute using a management of change process. And then we also have these items that kind of go across the entire life cycle. And those are going to be things like functional safety assessment, auditing, and the management that we're talking about today. So all these tasks need to be planned. You need to determine who is going to do them. Are you going to be able to subcontract them? What are the requirements for competency of the people who are going to be performing these tasks? All that needs to be developed and documented. Okay, so if I go a little bit further into section 6.2, section 6 talks about the safety life cycle. So that's where the previous figure came from for what the safety life cycle is. And that section gives more requirements on how to implement the safety life cycle in your organization. So the SIS safety life cycle incorporates the requirements of the standard, and it needs to be defined during safety planning. And what is safety planning? It's going to be the development of that site standard, that corporate standard that explains how safety instrumented systems are executed in any particular organization. Okay, and safety life cycle planning needs to address not just the hardware aspects, but also the software aspects of the design of a safety instrumented system. Safety instrumented system guidance addresses the entire life cycle. So from beginning to end, and all of the management, assessment, auditing, and verification tasks all need to be planned in your corporate guidance document. So you need to address the entire life cycle. And again, the best way to do this is to have an overall guidance document. But then you don't want your document to be too huge, especially when there are special areas that are considered during the safety life cycle. So during the safety life cycle, for instance, you might need to do a hazard and risk analysis that is going to tell you what safety functions you should be considering. That might be done using a HAZOP approach. Well, it doesn't make sense to have a full explanation of how to do a HAZOP in your safety lifecycle planning document, in your functional safety management document, which is why you should start with an overall guidance document, but then have separate specific procedures for specific tasks. So a procedure for how to perform a HAZOP, a procedure for how to perform a LOPA, a procedure for how to write safety requirement specifications, a procedure for how to perform SIL verification calculations that is going to be specific to the way that you do it in your organization. Okay, this document is going to detail out the requirements for every phase in the SIS safety life cycle. Okay, going on a little bit further, you need to define each phase, each step in the safety life cycle in terms of its inputs, the outputs, and the verification activities that need to occur for that phase. So there's a phase called hazard and risk assessment. There's a phase called allocation of risk reduction to independent protection layers. Each one of those phases, you need to define in your organization's language, what are the input documents you should expect to receive? What are the output documents that you should expect to generate as a result of that activity? What templates should you be using as a starting point? What tools should you use to perform those activities, and any other constraints that are imposed by your organization for those tasks all need to be listed out in this document. Okay, so this needs to be done again for every activity, every step in the safety life cycle, every activity that's going to occur when you're performing an SIS project. So those inputs are going to include things like the process safety information, the design documentation. The outputs are what you expect to achieve. And then verification is really important. Who is going to check to make sure that those deliverables were executed properly, and what are their qualifications? Who do they report to? What resources do they have available is all critical to have in this type of document. Going on to clause 6.2.3, for all the life cycle phases, planning needs to take place that defines the activities, the criteria, techniques, measures, procedures for the organization and the people that are responsible for the different activities. So we need to make sure that the SIS safety requirements are achieved for all modes of operation. We need to ensure proper installation and commissioning. We need to ensure the safety integrity after installation. So we're going to write requirements not just for the design phase, but also for the operational phase. Maintain the integrity during operation. So we necessarily need to assign tasks related to proof testing and failure analysis. And we also need to manage the process hazards during maintenance activities. Okay, going on a little bit further in clause 6.2.4, we state that if at any stage changes are required, once you make a change, you need to follow an elegant management of change process and procedure that is going to ensure that your safety integrity level and tolerable risk is achieved after the design changes are put into effect. And when you make a change late in the life cycle, it can significantly impact earlier stages of the life cycle. So for example, if you change the type of transmitter you're using in a safety function, that is going to impact the achieved SIL, so you need to redo SIL verification. It's going to impact your safety requirement specification, so you need to redo that. It's going to potentially impact your testing requirements. You may need to test more frequently depending on what the device that you replaced in terms of their failure rate characteristics. Okay, so the procedures that you're writing should include a means for identifying when earlier life cycle phases are impacted and trigger a review of those earlier life cycle phases as necessary. And of course, I would say that the 6.15.11 standard pays a little bit too much attention to programming. Programming is a very big deal if you're writing in C# or Pascal or Visual Basic, high variability languages. But if you're using limited variability languages, which you should be if you're following the 6.15.11 standard, things like function block diagrams or ladder logic, it's a little bit more difficult to get yourself into trouble. But the key to this slide and the key to statement 6.3.1 is that software is part of your SIS design, and you need to document it and manage it exactly the same way that you're documenting and managing your hardware design. Okay, so that is clause a little bit of clause 5 and some of clause 6. Let me go back a little bit in terms of just management of functional safety, which was clause 1. Again, when we're developing this document, clause 5.2.1 says we need to have a policy and a strategy for achieving functional safety, identified together with the methods for evaluating their achievement. This policy and strategy is generally going to be a corporate standard or a functional safety manual, functional safety standard. And that standard is going to include, you have your corporate policy, but you're also going to be referring to a series of other standards and procedures and templates that you're using when you're executing projects. So some of the common ones would be a procedure for HAZOP along with a template and a software tool, a procedure for LOPA along with a template and a tool. SIL verification might include recommended failure rates, recommended tools, policies and procedures, report templates, safety requirement specifications, the same thing, and also policies and procedures for performing site acceptance testing. This all needs to be developed and standardized so that it's consistent among all the projects that you're going to execute. When we get into the planning, we're going to look at the organization and resources. So we need to know who is doing what and we're going to need to define what their competency requirements are. This is a big issue. There are a lot of less than competent people executing SIS projects. So kind of setting a floor to determine what experience, what training, what certification for these people is required is essential, along with a level of independence for tasks like verification, validation, functional safety assessment, and auditing. Okay, so safety planning needs to be done for all phases, and the safety planning needs to ensure that all aspects of the SIS lifecycle are addressed using company policies, guidance documents, and procedures. Okay, so with that, I'm going to back out of the PowerPoint presentations right now. The requirements themselves are pretty standard. And looking, if I could go back really quickly into the standard itself, because I've already showed you most of the clauses that are relevant. They're going to start here. Bear with me for a second. Let me get through the definitions and get into clause 5. But clause 5 is the key where all of these requirements sit. So we already talked about clause 5.2.1. It says you need to create a standard. And then 5.2.2 starts off into what needs to be included in the standard. So there's a lot of information about the people who are going to do the tasks. There's a lot of information about competency that I'm going to get into in just a second, which is key. We need to have a procedure in place to manage competence. We need to manage our risk evaluation and risk management. We need to do safety planning. And then there's also an implementation and monitoring activity to make sure all this work is done. So clause 5 is really important. It's going to lay out a lot of requirements for your management system, things that you need to consider when you develop your corporate policy. So now that we've talked about that, let's talk about the corporate policy itself. So we at Kenexis, if you look at the standard, it's going to give you a lot of requirements, a lot of things to think about, but it's very generic. The requirements are very broad, they're very vague. So what we've done is we've provided you with a Word document template to use as a starting point to be able to develop your own corporate standard. So it's an editable Word document. The first step is to insert your own company name into that slot and then start making modifications that are appropriate for your organization. You'll see that the standard that we have is not exceedingly long. It's about 13 pages. But as I mentioned earlier, it's important to remember that we are going to be pointing you to a lot of other locations. So this one document doesn't have everything that anyone who has any involvement in the SIS safety lifecycle needs to know. It is going to refer to a lot of other documents to perform details. But what we're doing in this corporate standard is setting an overall lifecycle management approach, hitting the high points of what's required in clause 5, and referring you other places like a LOPA procedure or an SRS procedure or a SIL verification procedure to get into the details of performing those tasks. So if we look at the standard, we're going to start with a just general purpose and scope. What does this standard apply to? What is a safety instrumented system? What types of risks are we going to consider when we're executing and using this procedure? Very standard. Normative references are going to include documents that you refer to. So what other documents are going to define the SIS safety life cycle? So we know for sure that the IEC 61511 standard part 1 is a normative requirement. You need to follow 1511, and this document is not intended to replace 61511, but to provide additional detail as to how your organization is specifically going to implement some of those details. Okay, so as you're going through this editing process, if you have other IEC, ISA standards that are going to be relevant to your organization. So maybe your organization has some machine tooling, you're going to want to include the machine tool standard. Perhaps your organization does a lot of boilers, you might want to incorporate NFPA 85 by reference for the boiler work. Perhaps you have higher level corporate standards, but you want to write a standard for your specific site. You might want to include those references to your higher level corporate standards. That's what you're going to want to do when you're editing clause 2, the normative references. Clause 3, very simple, very straightforward, just some terms, definitions, symbols, and abbreviations. All I've done here is listed out some of the acronyms that appear in other sections. Okay, now we've gotten through the front matter. Now we're going to get into the details. So this is the implementation of clause 5.2.1. What is the organization of your company and what are the resources that are going to be used to execute SIS projects? So it states that functional safety activities are defined in the standard at the site level. So the way that it's currently written, it's for the site level, but you might want to change this for a higher level corporate standard, and then you can implement those details at multiple different sites. Completely up to you. The organization and resources are going to be defined in a table that starts right here, down here on the next page. We'll get to it in just a second. So that table includes a step-by-step workflow that is in a lot more detail than the safety life cycle in the standard. So something like the hazard and risk assessment phase of the safety life cycle is broken into multiple different tasks with different inputs, outputs, and responsibilities. That's all detailed in table 2. Okay, so for each step, again, who does it? How do they do it? The table is consistent with the SIS safety life cycle as presented in the standard, but it does go things in a lot more basis. We also noted here that tasks 1 through 8 are chronological on a project-by-project basis, but tasks 9 through 11 are going to be management and admin tasks that occur all throughout the life cycle. So that's kind of an important thing to note, that this standard talks about not just project-by-project execution, but just day-to-day management activities related to the SIS. All right, so let's get into the meat of it, which is going to be the organization and resources table. So in the table, there are 5 columns. The first column is going to be the safety life cycle phase, and this is totally consistent with the 61511 standard. You see, we begin with hazard and risk analysis, move on to allocation, safety requirements, specifications, and so on. For each life cycle phase, there is 1 or more activities. So you'll see here, we broke the hazard and risk analysis phase into 4 different tasks. Now, this is Kenexis's best practice, best judgment. You might lump them together for your organization, or you might break them into more different pieces, depending on how your organization actually executes these activities. So you'll see that we begin with scheduling the hazard and risk analysis. There is a task for facilitating and documenting the PHA. There is a subsequent task of developing a list of independent protection layers and safety functions that were discussed in the hazard and risk analysis. Some people call this the rationalization step. And then there's also another task of just participating in the activity. So for each of these tasks, there is a role that is responsible for participating or leading that activity. So scheduling is done by a PSM coordinator. Facilitation, in this template, we have it done by a PSM coordinator, but maybe there's someone else. You need to decide who at your organization is responsible. Now, you'll note that there is a role here. And a role might be someone's job title, but some job titles have multiple roles. So in some cases, like down here, developing a list of independent protection layers and safety instrumented functions, we've assigned that to the role of SIS engineer. Well, a lot of sites can't afford to have a dedicated SIS engineer. So they have an instrument and reliability engineer, and one of the many roles that instrument reliability engineer executes is SIS engineer. So we felt it most prudent to describe these tasks at the role level, but other options you have are job description, just job titles, or you might actually, for your organization, want to put in the actual names of people who are going to be doing this. That's something that you're going to need to customize. For each task, there's an output that's generated. So for the scheduling task, it's going to be the schedule. For the hazard and risk analysis, it's going to be the PHA report, including the worksheets. For the IPL list, well, that's the IPL list. So those are the outputs that are generated as a result of that task. And then finally, in the last column, for the purposes of standardizing for your organization, you're also going to want to put what tools and what resources are going to be required for that activity. So for instance, for scheduling a PHA, you might use a scheduling tool like Microsoft Outlook. You might need a conference room. You might need web conference software to execute that. For actually facilitating and documenting your HAZOP study, your tool that we would recommend is using Kenexis Open PHA software, which allows you to document hazards and operability studies and layer protection analysis studies. And you will also need to use a certain procedure. So the way that we have this written, when you do a hazard and risk analysis study, you will use Kenexis Open PHA software, and you will execute that study in accordance with the layer of protection analysis SIL selection procedure for the company. So we're listing off all those tools and resources, whether it's a software tool, a procedure document, or a template. And if you're interested, we also have the template layer protection analysis procedure. Okay. Developing the safety instrumented function list is something that we recommend using the Kenexis Vertigo tool. And then this last task is the people who are expected to participate in the PHA discussions. So you'll see that we've set out a framework that looks at every SIS Safety Lifecycle phase breaks it down into tasks. For each task, it assigns a role that is responsible for executing that task, explains what the result of that task should be, and then explains what tools are needed, are expected, are required to be used when you perform those activities. So in this case, if for instance, you subcontracted work and the consultant who did the hazard and risk analysis used something like a risk graph to select SIL targets, you would be in violation of your policies and procedures, your functional safety management planning. And that type of violation would be identified during a functional safety assessment, which hopefully would require you to redo your hazard and risk analysis using LOPA prior to actually introducing hazards into the process. So as we go along here, you're going to see this type of approach extended to all of the life cycle phases, all of the activities. So the next life cycle task is the allocation of safety functions to protection layers. So that includes management of the implementation of recommendations that are going to occur during the hazard and risk assessment process, which will be managed by the PSM coordinator, and then it's going to generate recommendation, assignment, and closeout lists. And you could do that using either the OpenPHA software or the action item tracking dashboard. And then the hazard and risk assessment team needs to submit IPL lists to all the engineering disciplines that are affected. This needs to be done by the PSM coordinator. So this task is more than just safety instrumented systems. It's also going to include sending to the relief valve group all the relief valves that were credited in ALOPA. That would include sending to the process control group all of the alarms or basic process control functions that were credited as IPLs. And then obviously that also needs to include verification of all of the safety instrumented functions that were credited in the LOPA, HAZOP LOPA, and how much credit was taken. Okay, moving on is the SIS safety requirements phase, which is development of the SRS. That's done by the SIS engineer. The output is the SRS. And of course, we would recommend developing that SRS in the Kenexis Vertigo software. SIS design and engineering is going to include defining safety instrumented functions, performing conceptual design, laying out the equipment. It's going to include performing SIL verification, managing the implementation of recommendations, performing SIL verifications for modifications. Oh, actually, I need to update my template. I seem to have duplicated that task unnecessarily. So as you're doing your editing, that right there is a duplicate. You should probably toss it. Specifications, requisitions, programming of the SIS, and detailed design requirements. So again, what are the tasks in detailed design? Who is doing them? Most of it we have assigned to an SIS engineer, but in your organization, you need to think about this. So maybe the programming is done by the controls group. The requisitions might be done by a purchasing engineer. Managing recommendations might be done by the PSM group. Think about all these tasks. Who is doing them? What outputs are they generating? And what tools and resources are you going to use to execute those activities? So you see a lot of Kenexis Vertigo being recommended for the SIS design and engineering phase. Then we move on to installation and commissioning. So we need to install the equipment, commission it, which is assigned to a technician, manage punch list items, perform FAT, manage FAT punch list items, perform an SAT, and manage SAT punch list items to get them included. That is going to include technicians, that is going to include SIS engineers, and we recommend execution of those activities using the Kenexis OpScope software for executing procedures. Moving on, SIS operation and maintenance phase talks about the development of test plans, the development of procedures for operations to interact with the SIS, including the SIS equipment in maintenance management systems and spare parts systems, scheduling testing, performing the periodic tests, and performing repairs. So these are all activities that need to occur. You need to assign them to a group, to a role, and tell them what tools that they should be using, what templates that they should be using to perform those activities in terms of procedure tools, whether you're using paper or you're using a sophisticated mobile computing based procedure tool like Kenexis OpScope. And even things like work scheduling systems would include things like Maximo and SAP to schedule activities to occur, that being done by generally a maintenance planner. Modification, management of change, talks about when a change is requested, what activities need to occur. So reviewing all requests needs to go to the PSM coordinator. Reviewing changes that are impacting the SIS need to be reviewed by the SIS engineer. Decommissioning activities are essentially exactly the same as the activities that you would do for management of change. Now, the last three items, which are, well, actually, let me step back. I'll start with 10. Verification is kind of project related. It occurs step by step. There are two concepts in the standard to remember: verification and validation. So validation is your SAT. It's the physical test to make sure that the completed system works. Verification is the step by step, task by task, deliverable by deliverable back checking of drawings and calculations to make sure that they were prepared properly. So this is something that is defined in the corporate standard on an activity by activity basis. But as we move along, we get to other activities. So functional safety assessment is essentially an audit that is done on a specific project, but it's done by someone independent of the project team. So you're essentially auditing a project to make sure that all the policies and procedures of the company were followed. And a great way to do that is to use the Kenexis Open Audit template for performing functional safety assessment. And so a lot of activities related to functional safety assessment. And then section 11 is safety lifecycle structure and planning. So maintenance of this standard that we're talking about, making sure that it's always up to date, making sure that all the tasks have been assigned, making sure that people are competent to execute these tasks, and periodically reviewing work activities to make sure that they're getting done by the right people in the right format. And that the staff who are executing them are actually competent in their work. These are the management activities that also need to be included in the life cycle. So as you'll see, the core of this standard is going to be this table 1 that makes a list of all the tasks, who's responsible, what the outputs are, and what tools, policies and procedures that they're supposed to be using. We have given you a starting point. For your organization, you might want to add tasks or remove tasks as is appropriate for the way you do things. But now, we're not done, because we casually listed role descriptions, but we need to do a lot more to meet the requirements of the standard. What do I mean by that? Oh, sorry, I was looking for my mouse. So table 1 described a number of roles. So we need to explain what those roles are. So in the next table, we listed out who all the people are. What are all the roles that are associated with the safety lifecycle? What are their responsibilities, their job responsibilities, and who do they report to? And it's important for the people that they report to know that while they might not have SIS lifecycle responsibilities, people that report to them have SIS safety lifecycle responsibilities. So that's another key aspect to look at, defining what all the roles are, who does them. And for your organization, you're going to want to edit this to use the role names that are in use in your organization. And also, you might want to put in job descriptions that perform these roles. There's a lot of customization that you might want to do to make this table appropriate for your specific organization. Now, we talked a lot also about tools. So every one of those tools that was referenced in the task table deserves a little bit more explanation. So there ends up being a list of what are all the tools that are being used, and what are the situations in which those tools should be implemented. Now, moving on to the next section, here is a very interesting item, because you'll notice if I go back up to the table, when I go back up to the table, you'll see that I listed roles: PSM coordinator, SIS engineer. And then I listed those roles here. If you look at these roles, the expectation is that there is a company employee who is executing these roles. Well, the reality of today's chemical process industries is that a lot of times outside resources are leveraged. And you can't just hire the low bidder. You need to ensure that when you're using an external organization, that external organization has also done their safety planning. You, as the operating company, need to vet these external organizations and approve them to be able to perform tasks for you. So what we've done is we've looked at the different tasks that are commonly outsourced to outside companies, and we've put in a list of qualified external organizations who can perform those tasks for you. So obviously, we've put Kenexis in as a place to subcontract a lot of the SIS safety lifecycle work if you need to do that. But as you're customizing this template for your organization, you need to think about the organization. So for instance, installing SIS equipment is not something that Kenexis would do for you, but you might have a list of organizations that can do this. And maybe some organizations are qualified to work on SIS. Other instrumentation and control organizations are not qualified to work on SIS. So you need to go through a quality management process to review who your critical contractors are and verify that they have the systems in place to ensure compliance with the 61511 standard, especially related to planning and competency. Okay, so make a list of what organizations you're going to subcontract to, and you can even go ahead and put those organizations back up into table 1. Now, I already started down the road of talking about competency. Competency is a critical issue. So many SIS failures are the result of human beings not doing an appropriate design. Most of the failures of SIS are actually related to incorrect or incomplete specifications. Competency is a big deal. Now, in the 2003 version of IEC 61511, the standard simply said, whoever's managing needs to make sure people are competent. But in the new version of the standard, competency is given a lot more attention and a lot more significance. Specifically, if I go back into the standard, I'm looking at the standard now. This clause 5223 is new in the 2016 version of the 61511 standard. It says you need to have a procedure in place to manage the competence of everyone involved in the SIS lifecycle. And guess what? That means subcontractors too. You need to have a procedure to make sure that your subcontractors are competent to do their work. Furthermore, you need to do a periodic assessment to document the competence of individuals that are performing tasks. So competence, you need documentation to show what competence is and that the people who are executing work at your facility actually are competent. So how do we recommend you do that? Well, up in table 1 and in table 2, we had a list of roles of people. I probably shouldn't do that. Sorry about that. I shouldn't be writing on this. We had a list of roles of people who interact with the SIS. So what you need to do is determine for each role, what competence do they need? So for instance, the engineering manager needs to understand process safety management in general. Actually, let me go ahead and draw here. The engineering manager needs to understand what the safety life cycle is. The SIS engineering manager needs to understand who is implementing which activities. So for each one of those areas of competency, you can then define how does a person develop and demonstrate that competency. So for an engineering manager to understand process safety management, one of the ways that they could do that is to go into the Kenexis Process Safety Training Center and take the Kenexis training module, OSHA Process Safety Management and EPA RMP Overview. So you simply set up the class in the learning management system that they need to take, and they need to be tested on to verify that they understand the content of that training. So you do that task then for all of your roles. The PSM coordinator is going to need to understand things that are related to process safety, safety life cycle, how to facilitate PHA studies, how to use the different software that is going to be in their purview. SIS engineers need to understand how to do SIL verifications, how to write safety requirement specifications. So for each one of those activities, so for instance, in order to be competent at writing safety requirement specifications, perhaps they should be taking the Kenexis Process Safety Training Center module on safety requirement specifications and the using Vertigo software to make sure that they know how to use the software. So that this last row here for competence and training requirements, what you see right now is basically for each competence item, a training class. But that's not necessarily true. There might be, instead of a training class, there might be an operator walkthrough on the job training. It might be fulfilled by an external course. It might be fulfilled by the fact that you have a four-year degree from an engineering college. So there are a lot of different ways to demonstrate that you have achieved competence in a certain task or a certain activity. So this gives a list for all of the people that are associated with the SIS safety lifecycle, what competence they need and what we're going to provide them in terms of training to check to make sure that they've achieved that level of competence. Now, in terms of documentation, so there's a lot of that. In terms of documentation, what we recommend at Kenexis is the training matrix. So if you go into the Kenexis Process Safety Training Center, which I was already there, I don't know why I got out of it, you'll see that we have something called the training matrix. So this says for every employee that you have on the left-hand side, there are a list of courses that those people are supposed to take. And then you'll have the status information. So Alexis, one of our relatively new employees, has completed all of this training. So let's say she needed to do PHA facilitation. We go into Open PHA and we see that she's 100% complete with taking the training, but she did not complete the quizzes. So I'm going to have to go talk to her about, well, actually, using Open PHA doesn't have any quizzes. That's why that's the case. So green C means the course is completed and you're up to date. P means that the training is in progress. So she probably opened it up but didn't complete it. R means that that's a fine, oh wait, there it is. R means that they are registered for the course but haven't completed it. And if they are in the gray, so Cheryl is our inside sales, so she does not need to know how to use our using PHA software because she writes proposals. But again, this is the kind of tool that we're talking about for documenting and demonstrating that you have competence. What are the competence activities is going to be this list along the top. And then what do we need to confirm to what do we need to know to confirm that that competence is in place? It might be taking a test. It might be visual inspection of their work activity. It might be receipt of a degree from an external organization. But using this type of matrix is a great way to do that. Okay, going back to the standard. So we had competency requirements. And then the standard closes out with information and documentation requirements. So basically it says that when you implement safety lifecycle activities, that's going to generate documentation. Documentation on safety instrumented systems needs to be available to personnel that are involved in SIS safety lifecycle activities. So in order to ensure the documentation is always up to date, it needs to be, you need to define where these documents are going to exist, how the documentation is controlled, and how the documentation is accessed. Obviously, we would recommend your SIS documentation be contained in the Kenexis Integrated Safety Suite, which is going to allow you to store Open PHA studies for hazard and risk analysis, Vertigo studies for SIS Lifecycle Management, and Kenexis Process Safety Training Center for the competency and training requirements of the SIS lifecycle. So with that, that kind of gives you the big picture overview of the management process as a whole. And as you can see, this lays out the big picture for functional safety management, but it's only about 13 pages. After you edit it, it might be more or less than that. But it lays out who does what and how do we know they're competent to do it, and how is the work performed. But this standard isn't everything. It's still going to refer to other documents like a LOPA procedure, a SIL verification procedure, an SRS procedure that dives into the details of how to perform those specific work activities. But this is the first step, the necessary starting point to an overall activity, an overall management process for safety instrumented systems at your facility. So with that, let me go ahead and close out of my presentation and go ahead and turn the floor open to any discussion, any questions that we might have related to the content of this meeting. And I believe, Jim, can you please confirm that they can all turn their mics on if they have a question?
They should be able to, but let me just check real quick. No, the mics are not disabled.
Okay.
So, Shivendra, is that how you say your name? I apologize, but.
Yeah, very good morning to all of you, and thanks, Ed, for the excellent presentation.
My pleasure.
Yeah, I have a question. While you were referring to this documentation, the IEC 61511 standard edition that is mentioned is 2016. So there is an amendment in 2017-18 as well. So is there any major difference in terms of the management clause? Is my question, please.
Right. Well, I said 2016, but when I showed you the standard, I was showing you the fully amended version. So in the presentation, anytime I referred to a clause, it was in the fully amended version. To be honest, I don't know whether any of the amendments had an impact to management of functional safety, but again, the discussion, the referral to clauses, and the document that I showed you for the standards document was the 2018 fully amended version. Very good question, though.
Yeah, thanks. That answers my question.
Okay. Okay, so while anyone's still thinking about any questions that you might have, let me go ahead and let you know that this conference has been recorded, and we're going to publish the webinar video on our website. And so if you have any colleagues, or if you showed up a little bit late and you missed the beginning, we're going to have the full video available on our website, which is probably, I would say, 90% of the viewership views the recorded video instead of the live web conference. You know, that's society today. I will take that information when I'm ready for it. So any last questions before I turn it back over to Jim?
Yeah, and I have one question. This is Ezra Charles.
Good to hear from you again. What was it, last year, 2 years ago we had that training class?
December.
Okay, all right.
I have one question on proof test documentation.
Yes.
And is it anything stated in the standard on how long a time frame that those should be like signed off and turned in for auditing purposes, or that's just on the respective company?
So does that mean retention policy, Or are you talking about how soon after you execute the test do you need to file the paperwork?
Yeah. I mean, like, is it like how soon after the test? Is it like 10 days, or what's the time frame?
Well,
Oh,
all right. I will tell you this. The standard does not go into that level of detail. It just says, all it says is you need to document the test. It doesn't say you need to document it immediately. It doesn't say you have to use paper. So that level of detail is not in the document, which means you have to use your best judgment. And somebody like an OSHA, a regulator, is going to use the standard of the soonest that you can reasonably do it. So, something like 10 days is not unreasonable for paper documentation, especially if you did like 100 tests and you need to go back and issue the paperwork for all of them at the same time. I think 10 days is not unreasonable, but there is nothing in the standard that gives you a hard deadline.
okay. Thank you. And
Uh-huh.
my other question would be PHA frequency, and determine when you need to update your seal calculations.
Okay. Excellent question. Well, in terms of hazard and risk assessment, in the US, it's real easy, and most of the world has something very similar. So in the US, you're following the OSHA Process Safety Management Rule, and the OSHA Process Safety Management Rule says you shall revalidate your PHA once every 5 years. Period. End of discussion. So you're revalidating your PHA every 5 years. And when you revalidate your PHA, that is the trigger that says, well, if the PHA changed something in the LOPA, I need to redo the LOPA. And if the LOPA or the PHA changed something about the design of the SIS, changed the SIL target, change the risk levels, what have you, then that's going to trigger the redo of the SIL verification calculations. It might trigger the SRS and so on. So that once every 5 year HAZOP revalidation is going to be the trigger for other activities, but only if the PHA revalidation identified a change. If the PHA doesn't identify a change, it says, okay, whatever we have for an SIS is fine. We revalidate that everything's okay. Then you don't need to redo anything. It's only if the revalidation triggers that work that you need to redo it. And the revalidation by law, well, by regulation, which has the weight of law, once every 5 years.
Okay.
All right. Thanks.
Thank you.
Shivendra, you had another question.
Yeah, see, the thing is that this is more specifically from the Asian context, or rather more from India.
Uh-huh.
Okay, where I'm working. See, the
Yep.
thing is that as if I understand correctly, the IEC 61511 standard is neither a directive nor not a law anywhere, right? It is good practice.
Okay. Let's step back and say that is not specifically correct, because in the UK, for instance, the HSE has adopted 61511 and incorporated it by reference. So there's something called BS 61511, British Standard 61511, and that gives it essentially the weight of law. It's incorporation by reference. So some jurisdictions do that. Other jurisdictions do not. In the United States, for instance, the Process Safety Management Rule, which our regulator enforces, doesn't require you to use 61511, but it says that you need to design safety critical equipment in accordance with recognized and generally accepted good good engineering practice. And a lot of companies choose to use 61511 as recognized and generally accepted good engineering practice. Some of them don't. There are some major operating companies that don't do SIL, don't do the safety life cycle. They have prescriptive standards for how they design and maintain their safety function. So there's a little bit more flexibility there. And then there are other jurisdictions that are even looser in terms of a legal requirement to implement standards. And I have to admit, I do not know the legal and regulatory framework in India. And if you wanted to tell me a little bit about it, I'm all ears, would like to hear it.
Okay. See, thanks for your explanation. The thing is that IEC 61511 is a good practice even in India, in many companies, but not in all, specifically those that are following the process safety management program from OSHAs or from CCPS. So it is not a law as yet in India. So what usually happens is, I mean, the question that I wanted to bring to you is, it becomes quite difficult to convince the management, why do we need to prepare a functional safety management plan or a management document in itself? Because it is a very exhaustive document, and it becomes very tedious for people to manage and follow so many procedures, management plans and documentation and so forth. So they say if it is written in law, then you need to do it. That is how things work.
Yeah, understood. It's the global problem of the safety engineer who says we need to do this because it's the right thing to do. And if management says I've got no budget for you,
exactly,
not a whole lot that you can do. We're trying to make it as inexpensive and easy as possible, but some degree of management buy-in and commitment is necessary. Some jurisdictions, it's required by law. Other jurisdictions, you're completely relying on the company culture.
Right.
All right, so I have kept you guys over 12 minutes past when I was supposed to. I know that some people showed up late. We did record this, and we are going to post the recording up on our website probably sometime later today. So with that, I'll turn it back over to Mr. McGlone.
Yeah, I will. I'll have this, depending upon how long it takes the system to actually push it out, I'll try to have it up later today. So if you have some friends that want to watch it or anything, you go back to the same location. There's a link to recorded presentations or recorded webinars. And that page is actually under our resource tab too. And you'll be asked to re-register. I apologize for that, but there are so many people who watch this after they're recorded that we ask everyone to re-register just so we can keep track of who's looking at what interests they have in the topics that we present. We know that everybody wants to see technical content, so we try to do that as much as possible. And so you'll be able to re-register and get to that. If you don't register if you have not registered for our newsletter, please do that too. We don't spam anything. We don't sell our resources. We don't sell your information to anybody. As a matter of fact, I control your information, so it stays tightly inside the company. And the newsletter is basically a technical article and an invitation to a webinar. Typically, you can read it on your cell phone. It's designed specifically to do that. So by all means, sign up for the newsletter, and I'll try to have this posted later today. Thanks, everybody.
Excellent. Thanks, everyone. Have a good day.
Thank you.
Bye-bye.